Hello guys. So let's start with the problem maximum length of a concatenated string with a unique characters. So let's try to understand the problem statement. So array of a string is given, and by using this array of a string, we need to form a string by concatenation of the subsequence of given string that has unique characters. And in this way, I have to maximize the length of the string. Okay. So let's try to understand by the example one. So as you see, this is the given array of string. So in this problem, I have to choose the string and concatenate them so that the string that I finally choose, whose length is maximum and all the characters in that string is unique. Okay. Okay. So now in the problem, it is already mentioned that subsequence. So whenever the question in the problem, if it says about the subsequence, it means that again take not take, again take not take means recursion come into the picture. Okay, let's see how the answer is 4 for the example number 1. So if I consider the first string into my answer, so then I can also include the second string, but I cannot include the third string because in the first string u is already there. So in this way I will get my answer as a 4, that is already, it is the output, the final output is also 4. But if I don't consider the first string, if I consider the second one, then I can also consider the third. So by concatenating these two, again it will give me 4 as an answer. So as you see, again take not take. So basically it's a recursive problem, and as we know, by memoizing it, we can transform the recursive problem into recursive solution into a dynamic programming solution. So this is all about the problem statement and the given example test cases examples. So to get the more clarity about the problem, let's see. I am going to implement the coding part. Okay. So each time before taking before considering a string, first of all I have to check whether all the characters of that string is not, any of the character of the current string is not present in my answer string that I have considered up to that index. So for that I can take a frequency array of 26 length, or else I can take a integer variable, and will show each bit will show if if the first bit is 1, it means that the character a is present. If the second bit is 1, it means that the character b is present, or else if it is 0, it means that that character is not present. So int bitmap, initially it is 0. Now I am going to write a recursive function, that name I'm giving in as a helper. So arr, now just bitmap, and I need the size, arr dot size. So as we know, like in the take or don't take, one of the state is our size, the length of the array. So here the length of the vector is arr dot size, and another one is here bitmap. Before taking, I will check whether that character is present or not. Okay. So helper function again call arr bitmap and int n. Okay, write the base condition. If n equals to 0, then return 0. I considered one base index. Now, as we know, in the recursion, we generally do take or don't take. It means let's take initially take equals to 0 and not take. So not take, we can directly call our function, helper function again. So we are not taking this. So bitmap and n minus 1. Okay. Now, before taking, I have to check whether the bitmap that is storing the index of the characters, whether that character is present or not in the current string. So string cur equals to arr n minus 1. So this is my current string. So let's check all the character of this current string and also store it, so that if we will take, then we will just take a or of bitmap or new bitmap as a updated bitmap. Okay. Okay, so I need one more variable, that is new bitmap. Initially it is 0. Now first just convert this character into the its bit position, in which bit position it is representing. So just one and cs minus a. Okay, now check whether this bit is present in the bitmap or not. So bitmap take and with bit. Okay, and if it is greater than 0, it means that bits are present. There is a common bit in between. Or also check in the new bit, like each time I will update my new bit map, that is or equals to bit. So also check whether the same character, whether this current character is already present in new bitmap or not. So new bitmap and bit. If it is greater than 0, then I need one more variable as a flag. Initially its value is 0. So if this condition satisfy any of the condition, then make flag equals to 1 and break the loop. Now if flag equals to 0, it means that we can consider this current string into our answer. So first update the bitmap. So int update bitmap equals to new bitmap or bitmap. Now just call the again call the recursive function by considering this string into our answer. So just s dot length and again call the helper function up updated update bitmap comma n minus 1. That's all. At the last, return max of take comma not take. Let me run this. So as you see, till now I have written okay. What is it? String vector. Okay. Okay, again I did a mistake. Helper error, updated bitmap. Take. Okay, S is not there. This is current. Okay. CURR. The string is current. CURR. Okay, as you see, this is the recursive solution. So it's passing all the given test cases. Now let me show you how to convert a recursive solution into dynamic programming. So as you see here, there are two states. One is bitmap, another one is n. So the size of length, okay, and bitmap also. So here it's better to consider a unordered map because it have two states. So we are don't know what is the maximum value of bitmap, so it's better to consider map. So just take another map int comma again unordered map int comma int dp. So this is the unordered map dp. Now just two more steps are required. Just before, wherever are you returning, first store it. First store and then return. And the one more step, just check whether the bitmap and the n is already calculated or not. So if it is calculated, then it is present in the our dp map. So let's check. So dp dot count n, if it is, it must be greater than 0, and dpn dot count bitmap, it also must be greater than 0. It means that the value is already calculated. So just directly return dp of n comma count, sorry, bitmap. So let me run it. So okay, unordered. Okay, okay, yeah. Okay. So even ordered. Okay. So as you see, by using just adding just 3 lines, I have converted the recursive solution into a dynamic programming. So let me submit it. So the time and space, if I talk about, so the okay, the solution get accepted also. And if I talk about the time and space, so the time is basically the first state, that is n, is given in the problem, that is 16. So the n, the max n becomes 16. And also here I am doing a for loop inside my recursion, and it have max length as a 26. So again n into 26. And this bitmap, if I talk about, so bitmap is maximum 26, because maximum 26 characters are possible, and this bitmap is just for considering 26 characters to check whether that character is present or not. So this bitmap is representing those characters, whether those, if the bit is 0, it means that character is not present. So it is also maximum 26. So n into 26 into 26 is the time complexity of this problem. That's all for this problem.